Hey, welcome to Nx Conf Lite. I hope you've been enjoying it so far. My name is Colum Ferry. I'm a senior software engineer, and I'll be talking to you today about supercharged micro frontends with monorepos. But first, what are micro frontends? Micro frontends is a term given when a host application, a large application, your normal application, has been split into multiple slices, which are normally feature specific or domain specific, where each of these slices or remote applications are deployed independently from every other slice and the host application itself. This allows teams to completely control the release and development cycle of their own slice of the application without worrying about when the host is releasing or when the other remotes are releasing. Then at runtime, the host application will just fetch each of those remote applications and load them onto the application. At the end of the day, users never see this technical implementation detail, but it allows teams to develop independently. So why do we need them? I kind of touched on it already by saying that it allows teams to deploy and work independently from other teams. But when does this become a use case? When do we need to actually think about this? And that becomes a problem for large organizations that are scaling out their engineering department, especially if that engineering department is becoming global, where you have different teams in different time zones. Coordinate releases between different teams in different time zones gets really difficult, especially in a world now where we're moving more towards remote work. We can see this happening more and more often, where we have different developers and different teams in different time zones around the world. So by using a micro frontend, we can then leverage the independent deployability aspect of them to allow a team in San Francisco to deploy and release their code, regardless of when your team in Ireland is regarding and releasing their code. At the end of the day, the host application doesn't mind as long as it can find it. So this allows organizations to iterate faster on separate aspects of the application, certain domains or certain features, without having to spend weeks trying to figure out when to release everything together so that all teams' code is live and ready at the same time. And by making this silo of slices with your application, you increase the maintainability of your overall application, because any change you make now to your slice of the code is less likely to impact anybody else's. You're not going to introduce bugs on some other team's code because you're only really focused on your own single slice. But micro frontends aren't new. They've been implemented before, so why is everybody talking about them again? Why have they become so popular? Well, it's worth taking a look at what was used beforehand to implement them. And iframes were probably one of the first introductions to what micro frontends could be. And in fact, Google uses iframes as part of their internal micro frontend solution. Then we can see other takes on it, such as it's a script tag that may run code on load or after a certain event has happened. And then we've got server-side template composition for things like Nginx using server-side includes, or web components where we bundle pieces of components or a piece of an application as an agnostic bundle that can be loaded into vanilla JavaScript or any other type of JavaScript. There's also been micro frontend frameworks that have been built, like SingleSpa, to try and solve this problem. But Webpack 5 really came out and knocked the ball out of the park. It launched the Module Federation plugin, which is probably the best solution that's come out for implementing micro frontends. It abstracts everything into a neat package of how you think about your host application, your remote applications, what your remote applications need to expose, and how it all links together. And as part of that, the Module Federation plugin has two forms of federation, as it's called, where the host application is told you need to look for these remotes and where they will be. So static federation would be that the host knows to look for its remote applications, its slices of state, at a certain location, and it gets told that at build time, but it still doesn't fetch them until runtime. But it knows where they are at build time. And that's very important, because it means that if you're moving your built artifact across environments, you may have to rebuild your host for each environment so that it knows where all the remote applications live on, say, your staging environment or on your production environment compared to your development environment. Whereas with dynamic federation, we leverage the ability for you to tell Webpack at runtime that you need to know, that the host needs to know about these remotes and this is where they'll be. Now this happens at runtime, and the Webpack gets told about this at runtime, which means you can build your application, your host application once, use an API call or something like that to fetch what remotes the host cares about and where they live. So that allows you to then build your application, your host application once, and just take the same build artifact and take it across all your environments, which is much a preferred way of moving your code across environments, because if you're rebuilding for every environment, you may introduce issues where the rebuild is introducing a bug which only exists in one environment. Now, dynamic federation does give you this benefit, but it comes with a cost. It's more difficult to implement. You have to write code that fetches the remote application definitions, what remotes you need, where they are. You also need to be able to then write code to tell Webpack, okay, when the request is made for this remote, and you need to do this, and you need to fetch this container from this location, and then you need to tell Webpack's module loader that this is the container for this remote, and it's a difficult setup to get right. And Micro Frontends in themselves just aren't perfect as it is. If we take a look at the ThoughtWorks radar, we can see that in May 2020 and October 2020, Micro Frontends did feature on both of these radars. However, in May 2020, we were being told to adopt them, that they solves a lot of problems in the front end space. But by October, we were being told to hold off on them, that there's an issue here that we shouldn't be using them. And that issue is Micro Frontend anarchy. People saw Micro Frontends as the ability to free themselves from all constraints when they were building their slice of the application. So no longer did they think, oh, Team B is using Angular to build the application, we need to use Angular. No, people saw Micro Frontends as a way to say, well, we are completely agnostic to this team. We're building in a different slice, isolated completely from this other team. We should just use React because we know React and we like React. Which is fine. Micro Frontends do let you do that, but at this point, you're introducing a lot of different maintainability issues, and it just becomes a very difficult mess to keep it on top of. If product comes along and asks you to change the appearance of a button, and you've got 3 teams using 3 different technologies and 3 different styling solutions, then one piece of work is now duplicated into 3 pieces of work. If you've got 10 teams, is that 10 different pieces of work for one slight change? Because you're all using different technologies, you're all using different styling, which is replicating and duplicating code as well as work. This massively slows down the iterative process of your development. Consistency across the Micro Frontend architecture is key to ensuring that your Micro Frontends work well for the user and scale efficiently across your organization. There's actually a good talk by Rado Kirov on power and constraints, where actually putting constraints on your system allows you to be more successful over a longer period of time because you're used to working with certain technologies in this case, or certain styling solutions. So where do monorepos come into this? Well, monorepos in and of themselves allow you to co-locate code, but it's not just that. By having all the slices of the application beside each other in a monorepo, we can see straight away if any change we make does actually impact one of the integration points of any of the remote applications in the overall architecture. It also means that we can create a shared component library that can be used automatically by all the slices and all the remotes. Now think back to that example of a button appearance change. We make one change in the monorepo and all the Micro Frontends, all the remote applications benefit from this change automatically because they're just sharing code straight from within the same sources. A Micro Frontend usually helps to enforce a single version policy, which for Micro Frontends becomes really important when you're thinking of mixing Angular versions or mixing React versions, where some React code may be incompatible with other React code of different versions. Whereas if we make sure that all the remotes, all the slices are always on the same version as each other, then those maintainability issues, those bugs that could crop up due to versioning just won't happen. We're eradicating a whole list of bugs that could potentially be introduced into our system. And of course, we get an increased developer experience because of all this. We can see if our change does affect anybody else. We can then reach out to a specific team that this change may affect, rather than saying, oh, we've made a change, you may be affected by it. And of course, we increase the reliability because, again, any change we make, we can see if it impacts. We can see if unit tests from other applications fail because we've impacted them, or we can see if the end-to-end test or behavioral test of our full Micro Frontend architecture has been impacted by our change. So any cross-cutting tests that take us through different slices of the application can then be tested from our own code change before we deploy, before we commit that change. So what does Nx offer in terms of micro frontends? Well, Nx is fully committed to providing the best out-of-box micro frontend support, and we do this by providing abstractions over some of the Webpack config over the Module Federation plugins configuration, by offering helper methods to help you set up this configuration, to help you share workspace libraries and share npm packages. And of course, we wouldn't be offering support if we didn't offer generators that help you scaffold out your micro frontend architecture with ease, knowing that everything will be wired up and in a consistent manner that we find is one of the best practices. And of course, with Nx, you always get the powerful tooling of the affected command, of project graph analysis, of caching, etc. And out of the box, we're now able to support React and Angular for micro frontends. So let's talk through some of these common sense abstractions that we make for your module federation, for your micro frontends. This is an example of a host's Webpack configuration that we would have had to have to allow host applications to be able to find its remote where it lives. But it's very long, it's very verbose. Why should we be worrying about making sure that this lengthy piece of code works when all we care about for our host application is two remote applications? We can simplify our configuration down to just the name of our host application and what the names of the remote applications that we worry about. And this is all thanks to the power of Nx and everything being close together and Nx being able to understand the workspace. We also offer helper methods. So our with module federation helper method takes the configuration that we can set up, that we have the abstraction that we've created, and it will build out a Webpack config similar to the very large one that we just seen, but without you having to worry about that, without you having to try and maintain that across all your applications or in your micro frontend architecture. And I mentioned at the start of this about dynamic federation and how it can be really difficult to set up and maintain and to implement correctly because you're working with Webpack code directly for telling its module loader where a remote application lives, and it needs to load the container in such a way that Webpack's module loader knows how to do that. Well, our dynamic federation helpers will just take that worry away and we will handle that for you. And again, two very simple commands to scaffold out your application, but two very powerful commands. And that's the host generator, which will generate your host application with all the configuration set up for you, and the remote application generator, which will allow you to pass a flag in to the host, and that will wire up that remote to the host application so that the host knows that this remote application, the slice of the application, belongs to it. And we also have a dynamic flag to help scaffold dynamic federated hosts straight from the get-go. Now, how about we see this in action? For this demo, let's assume that we're building an e-commerce website that has two distinct features, a search page and a checkout. In this example, we have an empty Nx workspace that contains the Angular and React plugins. Now, going back to our example, we want to assume that our micro frontend architecture contains an overall application, which will be the e-commerce app, and two remotes, which will be specific to the features, and they are the search and checkout. So how do we generate this with Nx? We would use the host application generator, and we give it the name of the host application, and we can tell it what remotes we need. Just search and checkout. It'll ask us what style we want to use. We'll just use CSS for now. And then it will generate all the files and applications that we need for our micro frontend architecture. It'll also install any additional packages that are needed to compile the apps. If we take a look at what was generated, we can see in our apps folder we now have 3 new apps: checkout, e-commerce, and search. By first looking at the e-commerce app, we can see that there are 2 points of interest, and this is the module federation configuration file and the Webpack configuration file. So we take a closer look at the module federation configuration. We can see that it's a very simple configuration. We just give it a name and we say what remote apps this host application depends upon. or we'll try to find at runtime. It's the search application and our checkout application. Now, if we look at our Webpack configuration, we can also see that it's pretty much bare bones in the sense that it's using a helper method that we have created with an Nx called with module federation, and we pass it in the configuration file object that we created in our module federation. And this was all done automatically with our generators. Now, if we take a look at how this host applications module federation config file might differ from our remote applications, we can see that instead of specifying remotes, this remote application only specifies what files it actually exposes. And these exposed files are what can be consumed by the host application. If we take a look at the host application's source, we can see that in our app tsx file, we have some links, and then the React router is used to actually route to each of these remote applications. If we take a look at what checkout is, we can see that all it is an import from checkout/module. Now, this doesn't exist at build time. Webpack will then find this at runtime by mapping the remote name checkout to the exposed file from the remote application, which this /module matches the /module that's exposed in the remote application's configuration. If we serve our host application, if we serve our e-commerce host, it'll first build our remote applications, search and checkout. And it will serve them statically with a HTTP server, and then it will build itself and serve. So we take a look at what's generated. We can see we've got a home, a search, and a checkout, and this is our standard host application. Now, if we pay attention to the network tab, when we click on one of our remote applications, such as search, you can see that there was a couple of network requests made. One of these was a remote entry file. And if we take a look at where this actually came from, you'll see that it's on a different host or different port than our actual host application or e-commerce application, as are each of these bundles. And each of these bundles is actually what was fetched at runtime with Webpack. And you can see that it actually has changed what is rendered here on our application. So we click on each of these, we can see that it's all changing from e-commerce to search to checkout. And it's all happening at runtime, and it happens through a network request. But Webpack takes care of that, and all we do is use a simple dynamic import. Webpack takes care of the rest. However, when we just run serve, we serve everything statically. So if we look at our search application and try to make a change here, when we save this file, there's no change, nothing happened, we didn't reload. That's because these remote applications are served statically. They're built once and served. Now, the benefit of this happens when we try to serve our application again. Next time, any apples that hasn't changed will be taken from the cache. As we can see here, Nx read the output from the cache instead of running the command. And it did that for the checkout app because it didn't change. However, then the search page did change, so it had to rebuild. And once it was rebuilt and reserved, we see the changes. Now, you might not think that this is going to get tedious if we have to keep rebuilding for any Micro Frontend or any remote application that we're constantly working on. But the serve executor for our host application actually accepts a flag called dev remotes, which lets us specify which remote applications we want to be able to serve at the same time as our host, which will allow for hot module replacement. So we run this serve again. We can see that our checkout again was taken from the cache, and now each of our host application, our e-commerce application, and our checkout our search application were both built and being run live with Webpack Dev Server. So if I make this change again now to our search remote, we can see that it did replace that automatically and through a live update. This is great, and it means that we can scaffold out a Micro Frontend application easily. We can develop in isolation our own sections of the application without worrying about other remote applications and having to rebuild them and have them served or taking up memory in our whilst we're developing. It also means that if there's cache created at CI for all those other remote applications, then the application that I'm working on will serve fine, and I'll just get the cache hit from every other remote application in the whole architecture. But you may come along and think that, okay, now we have built out these features, we actually need a new feature, and we want this to be owned by a feature team that can deploy autonomously, so we need a new remote. Well, we offer a generator for that as well. It's the remote generator. So let's say that we want now for people on our e-commerce site to be able to manage their accounts. So we want an account remote. So we can create an account remote application very easily with the remote generator, but we can also tell it, okay, this is going to belong to our e-commerce host application. And when we run this command, again, it'll ask us what style sheet we want to use. We'll keep it consistent, use CSS. We can see that a new application was created called count. It's got a module federation config, it exposing the same module. But what's interesting is if we take a look at our e-commerce application and take a look at its module federation configuration, we can see that it actually added this account automatically for us. So out of the box, we can then attach new remotes to existing host applications. Now, a common feature for remote applications is potentially the ability to be able to share state between them. You want to create a shared data access library that will be used by the search and the checkout applications. So we generate this library, and then we will simply change this shared data access file to standard TypeScript file, and we will export an object that we can update within our search application. In the search application, let's set the value of account.name. And we will set it in an effect. Now, if we serve our
Now, if we serve our application, our host application, with our two remotes, search and checkout, as we're working on both of those at this time, then our account should build from cache and be served statically, but our host, our search, and our checkout should be built with Webpack Dev Server. Now, as we can see, we've now set our name for our account application on search. Now, if we go to the checkout page and we attempt to do the same, so let's copy what's here. In our checkout app, instead of setting it to Nx Conf for now, let's comment this out. We can see that it's taken the same state that was set in our search and is using it in our checkout application. So this state is being shared between our search application and our checkout application. And it's happening through Webpack, where Webpack is creating a singleton for this shared data access library. And it does this automatically with Module Federation helper. Our with Module Federation helper analyzes the project graph to see what libraries each application depends on. As you can see here, shared data access is used by both checkout and by search, and therefore this application is automatically wired up using our with Module Federation helper to be shared as a singleton between the checkout application and the search application. And it does this automatically. So anytime we create a shared library between multiple remotes, we no longer have to set that library needs to be shared and it needs to be a singleton. Webpack will with Module Federation and Nx will take care of that for you by analyzing the project graph.
So hopefully after seeing this demo, you'll have understood some of the more important parts of our Micro Frontend support and how we scaffold out our applications and how it makes everything a lot more easier to work with. But let's see what happens under the hood in some of these cases. So our abstracted configuration, we have two remotes here to do in login. Nx uses its understanding of the project workspace to find the to-do application, find where it will be deployed during development, and it will tell the Webpack configuration that this is the location of this app. And again, it does the same for login. Nx will also use the project graph to find NPM packages and workspace libraries that each application in the Micro Frontend architecture is using, and it will set it up to be shared as a singleton. By sharing it as a singleton, it means that we're enforcing a single version policy. So if any of these libraries change that affect multiple applications, we should deploy all these applications at one time to ensure the highest consistency in all the integration points. This also makes it easier for people to create new remotes or create new shared libraries, because beforehand, creating a shared library for a remote application or for multiple remote applications would have meant going into the configuration file and adding a new entry into the shared modules. Whereas now it happens automatically. You create a new shared library and the project graph knows that it needs to be shared and it will do it for you. Nx also exposes helper methods for when you can't use our with Module Federation helper. So if you're still stuck to using a verbose Webpack configuration file, then we have helpers that help you share packages. Again, we can't analyze the project graph here to say, okay, this is the ones you need to share. However, it does let you very easily share them. And again, we offer the same helper for workspace libraries. If you have any questions, I'll be on the Q&A panel, and or you can feel free to reach out and connect on Twitter. My Twitter handle is Ferry Colum. Thank you for watching.